Hello everyone, I'm Monika Bhushan and today we are starting lecture number 14 of linear algebra. So in today's class we are going to see Gauss-Siedel method to solve the system of linear equation. Since two classes we are seeing the different methods to solve the system of linear equation. So to solve the system of linear equation we have two approaches, okay? One approach is what? We follow the direct method, okay, and the second approach is what? We follow the iterative method, okay. So what is this iterative method? We actually perform the operation repeatedly, fine. So this direct method actually gives us exact solution, fine, and this iterative method gives us approximate solution. So which method comes under direct method? We have seen Gauss elimination method and we have seen Gauss-Jordan method. So these two methods actually come under direct method. Today we are going to see Gauss-Siedel method. Gauss-Siedel method actually comes under iterative method. So what is this iterative method we are going to see? This method is somewhat different from our previous methods where we have seen Gauss elimination and Gauss-Jordan method. There we were getting the exact solution, okay? But now in today's class we are going to start with an approximate solution and then we will improve the accuracy by repeating the same process, okay? So what is the need of this Gauss-Seidel method if we were using Gauss elimination and Gauss-Jordan method? Here also we are going to solve the system of linear equation. But not always each and every equation can be solved by direct method, okay. Some systems are little complicated, will get solved easily with less calculation using iterative method. So for those systems we are going to see Gauss-Seidel method. So we are going to see the process of Gauss-Seidel method. So this Gauss-Seidel method is what? This is an iterative method for solving a system of linear algebraic equations which is diagonally dominant, okay. Okay, so this is the prerequisite. We have to have diagonally dominant system of equations. So we are going to see what is this diagonally dominant equations. So here we are having three independent equations. Suppose this is the system which is given to me, okay, and then I have to check whether this is diagonally dominant system or not. So for that what we are going to check? We are going to analyze the elements which are present on the diagonal of this system. So since there are three rows, so we have three elements present on the diagonal of this system of linear equations. Fine, no? This is A11, A22, A33 are called as diagonal element. Okay. Now, for each and every row, I have to check this condition. And what is this condition? That the element which is present on diagonal, for the first diagonal, this is A11, second diagonal A22 and the third diagonal A33. So the absolute value of A11 should be greater than absolute value of all other elements which are present on that particular row. Okay, that means absolute value of A11 should be greater than absolute value of A12 plus absolute value of A13. Okay, similarly for the second row, this element A22 is present on the diagonal. So absolute value of A22 should be greater than summation of absolute values of all other entries. That means here A22 should be greater than absolute value of A21 plus absolute value of A23. Similarly, for A33, absolute value of A33 should be greater than summation of absolute value of A31 and absolute value of A32. Okay. So if this criteria satisfies, then we say that this system is what? This system is diagonally dominant system. Okay. Once we will start to solve the equation, it will be more understood. So basically what we have to do, whenever we have to use Gauss-Seidel method, we have to first check this condition. If this condition is not present, then we have to rearrange the equations so that the system will become diagonally dominant, and then only we can apply Gauss-Seidel method. Okay. So if this condition satisfies, then only we say that the solution exists as the iterative process will converge. So we will be seeing that what does it mean. Okay, so this is the question which we are going to solve. Fine, so here it is written, solve the following system of equations by Gauss-Siedel method to obtain the final solution correct to 3 places of decimal. Fine, that means what? That means the answer is not going to be exact answer, it is going to be approximate answer, but we are going to accept the answer if it is correct to 3 places of decimal. Okay, for that we are going to use Gauss-Seidel method. We are going to start with iterative method. Fine. So this is the system given to us. There are 3 equations and 3 unknowns x, y and z. We have to find the values of x, y, z correct to 3 places of decimals. Okay. So what we have discussed, very first step is what? We have to check whether the system is diagonally dominant or not, right? That means what? In my step number 1, what I have to check? I have to check that whether the system is diagonally dominant or not. Fine. So for that, what I am going to see? I am going to see that the elements which are present on the principal diagonal, which all elements are present on the principal diagonal. This is 1. Fine. No, if nothing is written, that means this is 1. This is A11. This is my A22. Right? 6 is A22 and 2 is A33. Fine. That means if I'll consider the equation number 1. So in that case, the element which is present on the principal diagonal, which is 1. So the absolute value of 1 should be greater than summation of absolute value of all other elements. So here again this is 1, nothing is written, that means 1. Fine. So the magnitude of A11 is 1. Magnitude of A12 is 1 and similarly magnitude of A13 is 54. Okay. Similarly, if I'll consider equation number 2, what I have to check? I have to check that the element which is present on the principal diagonal of the system. And which element is present? This A22 is what? This is 6. Fine, no? So the magnitude of A22 is what? This is 6. Whether 6 is greater than this 27, fine, no? Plus magnitude of this element. Okay, this is what? This is minus 1. Okay, so I am going to use only the magnitude of this minus 1. Okay, similarly for my third equation, this is what? This is what? This is 2. 2 should be greater than 6 plus 15, whether it is satisfying or not. So I can say that 1 is not greater than 55. Right now 6 is not greater than 27 plus 1. Right, I am not considering minus 1 because I have to take the absolute value of minus 1. So 6 is not greater than 28, 2 is not greater than 15 plus 6. Fine, no? So that means this system is not diagonally dominant. So what I have to do? I have to try to make the system diagonally dominant. Okay. And what is my try? I am going to do the rearrangement of rows. Okay, fine. I'm going to do the rearrangement of rows so that the system will become diagonally dominant. Okay, so that means if I will interchange these two rows, okay, row 1 with row 2, so what will happen? This 27 will go on the principal diagonal. Fine, no, I'm just trying it. So 27x plus 6y minus z equals 85. And then I'm writing down here x plus y plus 54, z is 110. And then third equation I'm writing down as it is. Okay, so in that case what is happening? Then in my principal diagonal, yes, this is my 27. 27 is greater than 6 plus 1. Fine, no? Okay, then I will check that if this 15 can come on this principal diagonal. For that I have to do the rearrangement of these two equations. Okay, so what I am doing? I am going to rewrite the equation. I am going to rewrite the system of equation in this fashion. Okay, so first row as it is, second and third I am going to rearrange. Okay, what is happening here? This is your 6x plus 15y plus 2z equals 72, and then x plus y plus 54z equals 110. Okay, so on my principal diagonal I can see that 27 is present, which is greater than 6 plus 1. Then 15 is present, fine. 15 is greater than 6 plus 2. And then 54 is present, which is greater than 1 plus 1. Okay, so this way I actually managed to make the system as diagonally dominant. That means now I can use the Gauss-Siedel method. But there are possibilities that system will not become diagonally dominant. Okay, if you are able to make the system as diagonally dominant, then only we'll say that the solution exists as the iterative process will converge. Okay, fine. Sometimes in the question they themselves will give you the diagonally dominant system. Okay, fine. So here we have done the same thing. Then we can see that this condition satisfies. Okay. So now we can apply the Gauss-Seidel method. So this was my step number 1. In my Gauss-Seidel method, always we have to check this step number 1. Step number 2 is what? Now the step number 2 says what? From equation number 1, I am going to write down what is my x. Okay. That means in my left hand side, I am only writing down x, and then all other things are in my right hand side. So it will be what I'm going to do. I'm going to write in my left hand side what is my x. Okay, so x is what? So here we see that 27x is nothing but 85 minus 6y. Okay, minus 6y and then plus z. That means x is what? X is 1 by 27 and then 85 minus 6y plus z. Fine. So I'm giving this name as 1. This is equation number 1. Okay. Now I'm going to consider equation number 2. From equation number 2, I am rewriting the equation so that my left hand side will have only the variable y. So this is what? 15y is 72. Okay, 72 minus 6x and then minus 2z. Fine. That means y is what? Y is 1 by 15 and then 72 minus 6x minus 2z. So this is my equation number 2. Similarly, I am going to consider equation number 3. From equation number 3, what I am going to write down? I am going to write down what is my z. That means 54z is 110 minus x minus y. That means z is 1 by 54 and then 110 minus x minus y. Okay, I'm going to give the name as 3. So this is my equation number 3. So this is my step number 2. Fine. Step number 1 was what? We had to rearrange if it was needed to make the system as diagonally dominant. Second step is what? I am going to write down what is my x, what is my y, what is my z with respect to the equation given to us. Okay, fine. Now what is my step number 3? So step number 3 actually starts with the iteration. Okay, that means what I am going to do? Here I am going to start with any trial solution. Okay, any trial solution I am going to assign for x and y and z. Here we have assigned 0, 0, 0 for x, y and z. Okay, it all depends on you. You might start with 1, 1, 1, 0, 1, 0, 1, 0, 1, anything. Okay, or sometimes in the question paper they will only give you that you start with this particular trial solution. Okay, so this is only the concept of iterative method. Here what we do, here we start with some approximate solution, and then after each and every iteration we are going to improve the correctness of the approximate solution. Okay, so these are the approximate solution, and then after first iteration, second iteration and so on, we will be improving this approximate solution. Okay, so this is the concept behind the iteration. These values are not unique. You might start with some other values also. Okay, okay, fine. So the third step is what? We are going to start with iteration. The very first iteration we write in this fashion, x, and then this 1 denotes that this is the first iteration. Similarly, y, 1 denotes this is the first iteration, then z1. Okay, fine. So what is my x at first iteration? So here we had written down the equation. Fine, no? So x is what? 1 by 27, 85 minus 6 into y plus z. And we started with x equals 0, y equals 0 and z equals 0. So in my first iteration, we want to know the new value of x. Okay. So the very first new value of x will be what? In my right hand side, I am going to use the value of y as 0, and in my right hand side I am going to use the value of z as 0, so that I will be getting some new refined value of x. Fine. So same thing we are doing here. we are using the value of y as 0, we are using the value of z as 0. So sometimes students get confused, what is my x value? So we started with x equals 0, right? And after this first iteration, we will be having new solution of x, new solution of y, and new solution of z. Fine. So we got here that x is 3.14815. Okay. Since they want us the accurate answer up to 3 places of decimal, so better to consider 5 places after decimal. Okay. So now what is my y1? So here we had said that this is the equation for y. So y is what? 1 by 15, then 72 minus 6x minus 2z. Okay, so since we got the new solution of x, we will be using the new value of x, right? Before computing y, we have actually got the new value of x. So this x we are going to put here, and the z is what? Z is 0 because we have not worked on z yet. And the x value, since we have got the new refined value of x, so we are using this value of x here to get the new value of y. Okay, so after this calculation, we have got this much, right? So to get the value of z, we are going to use these values of my x and y. So why we are not using the values of 0 and 0? Because to compute the value of z, I already have the refined value of x and y. Similarly, we are going to find the new values of x, y and z after my second iteration. Okay. So how do we denote second iteration? This is my x2, this is my y2, this is my z2. Okay. So what is my x2? The equation is given here, right? So the equation of x is this much. So we are going to use 1 by 27, 85 minus 6y plus z. Whatever the most recent value of y I have, or whatever the most recent value of z I have, I am going to put those values only. Okay. So new calculated value of y is this much. So I am going to use it. New calculated value of z is this much. I am going to use it. And then we got the new value of x. This value I am going to use to get the value of y. For z, I am going to use this value. So the same way I am going to perform for z, and then we will be getting the new values of z also. Okay. So but how long I have to do it? That means first iteration is done, second iteration is done. Now I'm going to follow the same process repeatedly for the third iteration, fourth iteration, and so on. So when I have to stop, so for that I have to check that after first iteration, whatever values I had got, and after second iteration, whatever value I am getting, are they same to 3 decimal places or not? They are asking us that the solution should be correct up to 3 places of decimal. That means up to 3 places of decimal, if the values are same, then we will stop there. But I can see that no, this is 3.148, this is 2.432. So I have to again go for another iteration. So the same process I am going to write down there also. It will be your x3. x3 will be what? 1 by 27, and then 85 minus 6 into y plus z. For y, I'll be using this value. For z, I'll be using this value. Fine. So same thing we have done here. Okay. Now, whether I have to go for fourth iteration or I have to stop here, for that I have to check the values of x, y, z. So after second iteration, the value of x was 2.432. Now here this is 2.425. Okay. They are not same. So we will be going for the fourth iteration. Okay. Same thing we are going to perform here also. I'm going to use new values of y and z. That means these values of y and z. Finally, I got some new values of x, y, z. Now I will be comparing these two values from the third and fourth iteration. Are they same up to 3 decimal places? So here we see that x after third iteration was 2.425, and x after fourth iteration, this is 2.425. Okay, so they are same. And for y, this is 3.572, this is 3.573, this is 29, this is 30. Okay, and then z is 1.925, 1.925. So here we can stop actually. Why? Because if you will think that this y value is not same, but 0.5729 and 0.5730 can be considered, and then you can say that the approximate answers of x, y, z are these three values. Okay, So we said that these three are the approximate answers. We cannot say that these are the exact answers. We will be always saying in Gauss-Seidel method that the approximate answer is this much. So some kind of error is also allowed in Gauss-Seidel method. So it all depends that what they are asking in the question. So if they are very specific that the answer should be correct up to 3 places or 4 places, then you have to do those many iterations so that it will be kind of same up to 3 or 4 places of decimal. But in the question, if they are not writing this kind of conditions, so then it's up to you when you think that you should stop your iteration. So because if you will analyze this third iteration and second iteration, you can say that the values of y are nearly same, correct? No, 3.572 and then 3.572. This is 1.925 and then 1.925. But in your x value after second iteration is 2.432 and here this is 2.425. So 2.432 and 2.425 are not very near. So you should go for another iteration. But in your exam, if you don't have time, you can stop after this iteration also. So this way we get the approximate solution using Gauss-Seidel method. If you find this class useful, please like and subscribe my channel. Thank you.